Mars moons Phobos and Deimos are not captured asteroids, says paper. Mars' mysterious moons of Deimos and Phobos have long puzzled planetary scientists. For decades, it was thought that they were simply asteroids that had been gravitationally captured into Mars' orbit. But in the last decade or so, planetary theorists have warmed to the notion that the most likely scenario for the origin of both moons stems from a large Mars impactor creating a debris ring around the red planet from which both moons may have coalesced. It's also possible that Deimos and Phobos formed from the same disk of material that formed Mars itself, some 4.6 billion years ago. Yet a new paper accepted for publication by the Planetary Science Journal confirms that neither moon was gravitationally captured by Mars. Today, the moons orbit Mars at average distances that range from some 23,463 kilometers for Deimos to only 9,376 kilometers for Phobos. Even so, the authors are still puzzled over whether Phobos, in particular, formed early or late. Phobos could have formed billions of years ago at more than twice its current distance from Mars, or it could have formed only 100 million years ago some 20% further away from Mars. Matija Cook, the paper's lead author and a planetary dynamicist at the SETI Institute in Mountain View, California, told me via email. NYT Many Today, Hints, Clues, and Answers for Tuesday, April 1. South Korean actor Kim Soo-hyun denies underage dating allegations. Women's Final Four in Tampa said, AT&T brings the energy. The team's simulations are unique. We included lumps in Mars' gravity field, and also the full gravity of the Sun, says Cook. Our model also used direct numerical simulations, meaning that we modeled orbits from scratch and do not use time-saving approximations, he says. Even so, the dominant hypothesis now is that they both may have formed from the aftermath of a large impactor that formed a debris disk around Mars, says Cook. As for their being captured asteroids, Phobos and Deimos have orbits that are close to the Mars equator, indicating their formation from a circumplanetary disk, the authors write. This means that they formed there and were not gravitationally captured by Mars, says Cook. Yet Phobos is particularly puzzling. Phobos orbits faster than Mars spins, so it rises in the west and sets in the east, says Cook. Because of this, Phobos' own gravity causes a slight flexing of Mars' surface which over time causes this Martian moon's orbit to decay and move closer to the red planet's surface, he says.